Welcome back to The Explainer. Today we're tackling a really fascinating contradiction at the very heart of our modern tech world. We constantly hear about the cloud and artificial intelligence as if they're these invisible, ethereal concepts just floating above us. But the reality? AI has a massive, heavy, and very real physical footprint. Today we're going to dive right into the massive physical scale and the surprising environmental paradox of the AI boom. All right, here's our roadmap for today. We're going to hit the AI infrastructure boom. Look at those massive energy costs, how communities are fighting back, data centers in space, and finally, how AI is actually protecting solar energy.
Okay, let's jump right into part one, the AI infrastructure boom, basically building the physical cloud. I want to hit you with this first massive number, $650 billion. That is the projected spending by major tech companies on AI data centers in the year 2026 alone. Just think about that. We're talking about tech giants pouring astronomical amounts of cash into specialized, heavy-duty facilities designed strictly to handle the computationally intense workloads of training and running machine learning models. And that spending, it has a huge ripple effect. Get this, 70%. That is the staggering chunk of the entire global computer memory production in fiscal year 2026 that was purchased strictly for AI data centers. This massive demand actually exhausted the global supply of things like high-bandwidth memory, leading to a worldwide shortage. Basically, when AI wants memory, the rest of the consumer electronics world just has to stand in the line and wait.
So the crucial point here is that this incredible growth isn't exactly frictionless. We aren't just talking about spending money. We're talking about building massive physical structures right in people's backyards. In fact, by July 2026, local community resistance had actively blocked the construction of AI data centers worth a staggering $130 billion. People are putting their foot down. So why is that?
Well, that brings us to Section 2, the massive energy costs and the environmental toll.
Take a look at this breakdown. The power difference is literally night and day. A standard general-purpose data center uses about 10 kilowatts of electricity per server rack. But an AI-focused data center? It demands around 60 kilowatts per rack. Because the parallel processing required by AI, using all those specialized GPUs, is just so intense. These racks require 6 times the electricity. They are fundamentally different. Way hungrier beasts than the data centers we've been building for the last 20 years.
To put that crazy power draw into perspective, an average AI facility consumes the electricity equivalent of 100,000 households. But the mega projects currently under construction, those are entirely different monsters. The International Energy Agency estimated that some of the larger AI data centers could consume as much electricity as 2 million households. We're talking about a single facility drawing the power of a major city. It's wild.
And where is all that juice coming from? Look at the US data center power mix here. You can clearly see we are still heavily relying on fossil fuels, 40% from natural gas and 15% from coal. Actually, scratch that, it's worse than just relying on them. AI's thirst for power is so intense that it's actively slowed down and in some cases entirely reversed the planned retirement of coal-fired power plants. Energy companies are literally keeping coal plants open just to keep these AI servers humming.
Which naturally leads us to Section 3, communities fighting back and local resistance.
Because for the folks living near these sites, it's not some abstract climate debate, it's a hyper-local environmental toll. These facilities generate immense heat, so they require millions of gallons of water for cooling. Take Amazon's $11 billion project in Indiana, for example. Constructing it required pumping millions of gallons of water out of the ground, which actually led to state officials investigating whether this process caused residential wells in the area to run completely dry. Add in the constant droning noise of cooling fans, local air pollutants from backup gas generators, and the very real risk of grid strain and blackouts during peak usage, and yeah, you can see exactly why communities are organizing against them.
So, what's the solution? Enter Section 4, data centers in space, orbital infrastructure.
I mean, if we can't find the space, power, or water down here on Earth, why not look up into the vacuum of space, right? Companies like StarCloud, backed by NVIDIA, and tech giants like Google are literally putting GPUs on satellites. StarCloud recently launched a satellite equipped with an NVIDIA H100 GPU and successfully trained a large language model called NanoGPT right there in orbit. It was the very first AI model trained in space. I know, it sounds like pure science fiction, but this orbital infrastructure is being built as we speak.
All right, here's where we make a major narrative pivot. The big question, can AI actually help the climate? We've just spent a lot of time seeing how incredibly resource-hungry this tech is, but is it possible that the very same technology draining our earthly resources can actually be deployed to protect them? Let's explore that in Section 5, AI Protecting Solar and Defending Green Energy. As climate change makes weather patterns more volatile, AI is stepping up as this incredibly powerful defense mechanism. Here's how it works. First, AI systems ingest a massive fire hose of raw data from weather satellites, ground stations, and local IoT sensors. Second, they process all that data through deep learning and neural networks. And third, they predict extreme weather events with hyper-local precision. This is huge. It gives solar operators early warnings, hours or even days in advance, to secure their infrastructure before a massive storm even hits. And since weather isn't, one-size-fits-all, platforms like Easy Solar use AI to create totally custom regional solutions. For coastal areas dealing with hurricane risks, AI identifies the need for stronger mounts and corrosion-resistant materials. Out in the desert with extreme heat and dust storms, AI suggests wider panel spacing and automated cleaning systems. Up in the mountains, algorithms actively adjust panel tilts to shed heavy snow. It's basically customizing resilience based on the exact microclimate of that specific area.
So AI isn't just reacting to the weather, it's proactively designing better solar farms right from day one. These AI layout optimization tools track the sun's exact year-round path to find the absolute perfect tilt. They assess local wind behavior to figure out how to group panels so they survive gale forces. They even model heat distribution to improve ventilation and map shadow movements down to the minute. This ensures these wildly expensive solar installations don't just maximize their energy output, but actually survive severe environmental events. And that brings us to our final slide, and really the core provocative thought of this entire explainer. Are the immense environmental costs of building AI actually worth the environmental benefits of using it? It's the ultimate paradox, isn't it? On one hand, we are literally keeping coal plants alive and straining local power grids just to fuel these massive data centers. But on the exact same hand, the intelligence generated inside those centers is the precise tool we are using right now to optimize solar grids, predict climate anomalies, and engineer a renewable future. It is a delicate, incredibly high-stakes balance. And how we weigh that heavy physical toll against AI's power to optimize our world, well, that is undoubtedly going to define our future. Thanks for joining me on The Explainers today, and keep questioning what's really running behind the cloud.